Let's say I consider the motion of an object uniformly across the room at 2 meters per second. So I'm walking across the room at a steady rate of 2 meters every second. If I represented that with a particle diagram, I would start with one dot to indicate where I was. 1 second later, I would be 2 meters farther. 2, I would be 4. 3 seconds, I would be 6 meters. If I wanted to represent that on a position versus time graph, I get this. At 1 second, I'm at 2 meters. At 2 seconds, I'm at 4 meters. At 3 seconds, I'm at 6 meters. And this upward slant does not represent the direction of motion. Remember, I moved across the room. However, it does represent the velocity of that motion. Why? Remember, velocity equals distance over time. And distance or displacement can be represented by position, because the distance from the 0 point will be its position. We have position, let's call this distance for the moment. Distance. Distance over time. Well, what was its distance? 6 meters. What was its time? 3 seconds. Distance equals 6 over 3 equals 2. 2 what? Distance is in meters. Time is in seconds. So its velocity is 2 meters per second. That is the slope of the distance time graph is velocity. Suppose I were just interested in how fast something were moving at a given time. In other words, I wanted a graph that told me how fast it was moving at 1 second, 2 seconds, and 3 seconds. Well, I have that. At 1 second, I was moving 2 meters per second. At 2 seconds, I was moving 2 meters per second. At 3 seconds, I was moving 2 meters per second. And I was moving at 2 meters per second at every time in between. So, my line is straight across, indicating that the slope of this line is linear in a straight line, doesn't change. The slope of this line is equal to 2. That's exactly what I've graphed here. Suppose now I'm interested in just acceleration. Well, how much is it accelerating at 1 second? And how much is it accelerating at 2 seconds? And how much is it accelerating at 3 seconds? Well, if I were to see how much the velocity changed, because remember, acceleration equals change in velocity over change in time. Change in velocity over change in time. I notice that it doesn't change. It's 2 here, here, and here. So if I took velocity final, 2, minus velocity initial, 2, I get 0. Therefore, I conclude that my acceleration is 0 at any given time. Remember, the slope of the distance versus time graph is equal to the velocity. The slope of the velocity time graph is equal to the acceleration. This has a slope of 2, so I plot a line that shows me 2 here. This has a slope of 0, so I plot a line that shows me 0 acceleration here.